In this video, we will investigate several more examples of limits from a graphical perspective and introduce the idea or concept of one-sided limits. So considering in blue here the graph of a function f, we would like to answer parts A through D. So in part A, we're asked to find the limit as x approaches 2 from the minus of f of x. And what this actually means is the limit as x approaches 2 from the left. So to get that in words, the symbols that we see to the left is asking us to determine the limit as x approaches 2 from the left. So that is, as I plug in values close to 2, but still on the left-hand side, what are the function values going to approach? So if we think about plugging in values close to 2 on the left, well, looking at the graph, those outputs are becoming closer and closer to the value 3. So from a graphical investigation, the limit as x approaches 2 from the left of f of x is equal to 3. In part B, we're asked to determine the limit as x approaches 2. The plus indicates from the right. So the limit as x approaches 2 from the right of the function f of x. Well, if I think about plugging in values just to the right of 2 but not equal to 2, and I trace up to the graph, we see that those outputs are becoming arbitrarily close to the number 1. So as you approach 2 from the right, the limit of our function is going to be 1. Now, before going on to part C, let me state a property that is going to be very useful. Now, if a limit exists, so that is, let's say if the limit as x approaches some number a of f of x is equal to the number L. Well, the only way that can happen is if the limit as x approaches a from the left and the limit as x approaches a from the right are also both L. So this is true if and only if, that is to say something that is equivalent to this statement, the limit as x approaches a from the left of f of x is equal to L, and the limit as x approaches a from the right of f of x is equal to L. Well, looking at the example that we have, as we approach 2 from the left, we get the number 3. As we approach 2 from the right, we get the number 1. Well, 1 is not equal to 3, so we would say that the limit, in this case, does not exist. And the reason why it does not exist is because the limit from the left is not equal to the limit from the right. And then just to throw in another point here graphically, what is the limit as x approaches 3? So when we plug in inputs close to 3, what are our outputs going to be close to? Well, if we imagine approaching 3 from either side, if we trace up to the graph, we see that those outputs are going to be approaching the number 2. So as x approaches 3, f of x is becoming arbitrarily close to the number 2. So one more very similar example, and this time we'll go through it a bit more quickly. So part A, the limit as x approaches 3 from the left. So if I'm plugging in inputs close to 3 but on the left-hand side, we see that those outputs are becoming close to the number 1. In part B, the limit as x approaches 3 from the right. If I'm plugging in inputs close to 3 but from the right-hand side only, we can trace along our graph and we see that those output values are becoming close to minus 1. Now, for the limit as x approaches 3, from a graphical perspective, we see that we might be in trouble because from the left we're approaching one number, from the right we're approaching another. And what that tells us is the limit does not exist. And the reason the limit does not exist is because the limit as x approaches 3 from the left is not equal to the limit as x approaches 3 from the right. Lastly here, let's determine what is the limit as x approaches 2 from the left. Well, if we think about plugging in something just to the left of, but not equal to 2, if we trace along the graph, and here we're going to have to imagine that the graph continues as we might expect, we see that the graph is just getting, smaller and smaller in that negative sense. It's getting very large and negative. It just keeps going downward. So in this case, we would say that the value of that limit, in fact, is going to be minus infinity. And the reason is we have a vertical asymptote to our function at x equals 2. And as you approach that vertical asymptote from the left, we see that our graph is getting larger and larger and larger and negative, and it's getting without bound, which is a fancy way of saying that the limit is approaching minus infinity, something that we'll investigate a bit more in future sections.